Another Leetcode problem, 2067, number of equal count substrings. So for this problem, we are giving a zero index to string s, and which consists of only lowercase English letters and an integer count. So a substring of s is said to be an equal count substring if for its unique letters in the substring it appears exactly count times in the substring. So what is the meaning? Yeah. So what is a valid substring of s? So for example, we're gonna check the index 0 to 2. So from the index 0 to 2, how many a's? So there are 3 a's. So the number of the letter equal to the count. So this is a valid substring. Yeah. And also from b to c here, we have 3b and 3c. This is also valid. And from index 0 to index 8, this is also valid because we have 3a, 3b, and 3c. Yeah. Although the description is a little bit confusing, but according to the example, we should understand what is the meaning. Yeah. So a substring of s is said to be equal count substring. So we just check what is the equal count substring. If for each unique letter in the substring, so for example, unique letter a, b, c inside this substring, it appears exactly count times 3 times. So that is going to be, yeah, that's going to be a valid equal count substring. But how can we solve this problem? And to solve this problem, we can directly use the brute force. So according to the number of the count and according to how many lowercase letters, there are going to be 26 lowercase letters. So if there only appeared a, yeah, so the count of a gonna be 3 times. So if it only appears something like AB, so the count is gonna be 6 times. So the window size is gonna be 6. Yeah, but the window size can never be 7 or 8. It must be a multiple of 3. Yeah, so this means actually the window size is gonna be 3 times 1 until 26. Now we just enumerate all the window size. So the window size is gonna be the count times 26. And then we're going to use a fixed sliding window to solve the problem. Now this is the window size, it is L. It is C times 1 to 26. And then we're going to use a fixed window size, just a fixed sliding window to check if that is possible. Yeah. So the valid case is that inside the window, we're going to use a counter. So inside the counter, each character gonna appear exactly 3 times. Yeah, I think basically that's all about it. And let's start coding. So I'm gonna prepare a final result. It's gonna be 0. And then I'm gonna check all the cases. So definitely for I, in range from 1 to 27. And the length of the window is going to be I times the count. So if this window size is more than n, so n going to be length of the string. So I'm going to break it immediately. This is just to speed up, or we can also delete those lines. We don't need it. That is also okay. Now we're gonna define a counter. So this D gonna be a counter of, yes, gonna be an empty counter, and we're gonna prepare the left side of the window. It's gonna be L, and so the L gonna be starting from index 0. Now we just need to enumerate all the cases. So for RC, enumerate the string S. So DC gonna plus equal to 1. Yeah, so the condition is that if R minus L plus 1 equal to this fixed window size. And then we need to check if O, and inside there's going to be an item, so x going to equal to, all items going to equal to the count. Yeah, all the items gonna equal to count. X gonna equal to count for X inside the counter. If this is valid, I'm gonna update the result. Yeah, but after that I need to slide the window. But how can I slide? So before I slide the window, I need to update the left pointer. So it's gonna be D S L gonna minus equal to 1. So if D S L equal to 0, I'm gonna pop it out. So D dot pop SL. And then I'm gonna update the left pointer. Yes, I think basically that's all about it. Finally, I'm gonna return the result. Yeah, I think that's all about it. Let me just run it. I hope it works, but it didn't. Or X equal to 0. Let me just delete those lines. I think that is also okay. Basically, it is just the same code. Yeah, still, for the first testing case, I get a 0. Definitely, it is not okay. Yeah, how can we debug? Yeah, let me just check it from here. It seems here it never works. Yeah, let me actually just check the dictionary. Let me just check what happens for the dictionary. Yeah, it seems it is okay. We have 3 A's. This is gonna be a valid case. Yeah, for here this A equal to 0. And this is also a valid case. Oh, that is because, let me think about it. Yeah, I think this is a valid case. If R minus L plus 1 equal to this L, yeah, let me check the L as well. Yeah, so as we can see from here, this dictionary is A3 and L gonna be 3. And here basically I want to check if X equal to count for X in D dot values. Here should be values instead of the K, otherwise it will never work. Yeah. Now I think it is okay because we just need to check the values instead of the instead of the K of the dictionary. We just need to check the values. I think now it should be all good. Now let me just run it. Yeah, as you can see, it works. So what about the time complexity? So here we use a for loop. So here it is 26, and then from here, we just enumerate all the strings of the S. So let's check the length of the string. It is 3 times 10 to the power of 4. Yeah. 26 times 3 times 10 to the power of 4. So what left behind is about here. D dot values. Yeah, so what's going to be the dictionary? How many cases of the dictionary? Because there are 26 letters. Yeah. So for this tag, it's going to be another 26. So this is going to be the time complexity. So 26 times 26 times 3, it is around 1000. And this is the 10 to the power of 4. So the final time complexity is going to be 10 to the power of 7. That is why it is so slow. Yeah, because 10 to the power of 7 is really a big value for the time complexity. I think that's all about it. Thanks for watching. See you next time.